Hello guys, I'm going to be doing question 3 from homework 4, and this is a circuit that we're going to be dealing with, and we're going to be finding the output voltage across this 1 ohm resistor on the right using state space. And in order to do that, we need to find our state variables. And again, before we do that, let me draw our mesh current loops. So our one's going to be here, I2 will be here, I3 will be this long loop over here, or at the top. So our state variables are variables are the values that change with respect to time. Hence they're variables because time, does things like that. So we know the current across the inductor changes with respect to time. I call it IL. Voltages across capacitors change with respect to time as well. So we're going to call this one V2 because the capacitor here is the voltage drop across this common node. So call that V2, and the voltage across this capacitor on the right we'll call VC. So our state variables are IL, V2, and VC. And writing them in respect to time, we have because the voltage across the inductor chain is with respect to the change of current. We know that the voltage across the inductor has to be the voltage difference of the input voltage in V2. So we write that. And we know that that the current across passing through a capacitor changes with respect to voltage. So we know that dV2 of T is the difference of I1 and I2. And similarly, dVc is equivalent to the difference of I2 and I3. So these are the three equations we're going to be using for our final answer, but we need these in respect to their state variables, and we have I2, I3, and I1, which in our equations, and we need to find these in respect to the state variables as well. So let's start with I2. So we know that V2 is the voltage drop across the capacitor and the 1 ohm resistor. And so using KVL, not really KVL, well yeah, KVL, we have V of 2 equals to the voltage across the capacitor and the voltage across the 1 ohm resistor, which is I2 times 1 ohm. Therefore, I2 is V of 2 minus VC. Yay! We got that out of the way. I'm going to probably make this smaller so I have more room to do the math. So we got that. Next we have to find I1 and I3. And we know that IL is equivalent to the difference of I1 and I3 based on how I drew the mesh currents. So let's write that down. So in order to do that, we need to find I3 first to even solve for I1. Luckily, we know that using KVL, the voltage, we know that I3 times 1 ohm is equivalent to the voltage across the inductor and the voltage across the capacitor. And we know the voltage across the inductor is V1 input voltage minus V2 plus VC. And we don't have to worry about VI because that's input. So therefore we are left with I3 equals VI minus V2 plus VC. So 1, we found I3, and 2, we can plug I3 in there, giving us I1 after cleaning up the algebra. We have I1 equal to IL plus VI minus V2 plus VC. Yay! We found the 3 equations that we need in order to find just complete our equations up here that we need to write the final answer. So after plugging I2, I3, and I1 respectively, we end up having, well, dI, L, d, t was already in respect to the state variables, but we'll rewrite it anyway. So we have Vi minus V2 equals VIL dt, and plugging in I1 and I2 for dV2 dt, we end up having IL plus VI plus 2VC, and then lastly dVC dt. After plugging in our needed equations, we have negative VI plus 2V2 minus 2VC. So these are the equations we're going to be plugging in for our final answer in the form of state space. And let me set up our answer. So we have d dt times our vector of our state space variables, v2, vc, il, which is equivalent to large matrix, okay, not that large, times our state variables again, plus our input, because we always need input. So based on using our equations here and plugging in their coefficients into their respected positions in the matrix, for our first equation V2, we have 1 IL, 1 V initial voltage, and 2 VCs, 2. And we have, wrote that backwards. We have 0 V2s, 2 VCs, 1 IL, and 1 VI. Now for VC, we have negative 1 VI, we have 2 V2s, negative 2 VCs, and 0 ILs. And for IL, we have 1 input, negative 1 V2s, no VCs, and no ILs. Yay! We have for first part of our answer. Now we need to do the output. So we know that our output is y equals matrix here times our state variables plus our input. But we don't have any input for our output. So 0 here. So we know that V out consists of V2 minus VC. Therefore, plugging our coefficient values here into, I need to throw that. Into here, we have 1 V2s, negative 1 VCs, and 0 ILs. And that is our answer for the problem. I boxed that so horribly. But thank you. I hope this video was helpful. Sorry that was messier than usual, but I'll be posting this image along with the video. Thanks again for watching. Bye!